Welcome to lecture 18 on risk management and insurance. Until now, we considered insurance companies that sell a single insurance product. But now we turn to insurance companies that actually sell more than one type of insurance contract. Assume the insurance company offers two types of products, A and B, that produce different loss distributions. So this insurance company may sell travel insurance, and travel insurance then produces a certain loss distribution for the insurance company. Then maybe the insurance company also sells fire insurance, another type of insurance contract, and that also produces some loss distribution. Now, if those loss distributions are independent, then actually you can calculate the overall loss distribution as the convolution of the two distributions for A and B. So the convolution of the two loss distributions represents the distribution of the total loss of the insurance company. Each product, A and B, has its own loss distribution, and if those distributions are independent, then we can calculate the convolution, and this convolution, then is the overall loss distribution. I will make an example here. Now let's look here. That's insurance product A, and that's the losses. Maybe for insurance product A, four possible outcomes are: the insurance company has to pay nothing, or $1,000, $2,000, or $3,000. Now, this insurance product A could be, for example, fire insurance. Now, the probability that there is no loss, that there will be no insurance claim, and so the insurance company has to pay nothing, that probability, let's assume, is 30%. Now, the probability that the insurance company has to pay $1,000, let's assume that's 50%. And $2,000, 10%, $3,000, 10%. Now, when you add up those percentages, naturally, you get 1. When you add up those probabilities, you will get 1. Now, you also can calculate the expected loss here. Just multiply each loss with its probability and add up. You will get 1,000. Now, with insurance product B, the loss distribution is different. No, maybe that's now travel insurance, and A is fire insurance. Now, in B, the insurance company pays either nothing, $1,000, or $2,000. So insurance claims are either nothing, there are no claims, or a claim of $1,000 or a claim of $2,000. Those are the insurance payouts that the insurance company has to do. Those are the losses of the insurance company. Again, here's the probabilities: 40% probability that the insurance company has to pay nothing, 40% chance that it has to pay $1,000, 20% chance that it has to pay $2,000. Again, the probabilities will add up to 1. Now, the convolution I show down here. So the convolution is the overall loss distribution of the insurance company for the two products together. And you can calculate this convolution if actually the individual loss distribution for product A and B are independent. Now so possible outcomes are 0, 1,000, 2,000, 3,000, 4,000, 5,000. And here you have also the probabilities. Now, how those probabilities are calculated? Just for this cell here, for those 30%. So with 30% chance, the insurance company has to pay $2,000. Okay, that's an overall payment. Okay, it's a total loss that it can experience from both products. Now, so those 2000s can actually arise in three ways. For example, maybe product A creates no loss, but probably product B creates a loss, involves a loss of 2000. So A, no loss, that happens with 30% chance, and B, a loss of 2000, that happens with 20% chance. It's independent, so you can multiply the probabilities. So A, no loss, B, 2000 loss, so you can multiply the probability 0.2 times 0.3 times 0.2. This outcome has a probability of 6%. Now, similarly, okay, the 2000 actually may happen because product A creates involves a loss of 1000 and product B a loss of 1000. That's another way, okay, to have a loss of 2000. Now the chance is here 50% and 40%. So with 50% chance, we have a loss in product A of 1000. With 40% chance, we have a loss of 1000 in B. Together, we have again a loss of 2000. So actually, this okay will happen with a chance of 20%. And finally, okay, maybe so it's just a loss of 2000 in product I and no loss, okay, in product B. This will happen with chance of 10% and 40%. So with 10%, product A creates a loss of 2000, product B creates no loss with 40%. So that actually will happen with a chance of 4%, and we can add this up. So the probability of a loss of 2000, okay, is 30%, because the loss of 2000 actually can happen in three ways. Okay, product A no loss, product B 2000, or A 1000, B 1000, or A 2000 and B no loss. So there are three possibilities here, and each of those possibilities, okay, has its probabilities. Okay, you can calculate those probabilities and you can add it up. So the loss of 2000 will happen with a chance of 30%. And similarly, you can calculate actually the other cells. Now, for example, cell here, the highest loss, overall loss of 5000, you will see directly here. You see, in that case, you must have the maximum loss in product A of 3000 and the maximum loss of product in product B of 2000. The chance of this is 1%, 10% and 20%. So you multiply 0.1 times 0.2. So the chance of a loss of 5000 is actually 2%. 0.1 times 0.2. Okay, maybe check yourself, okay, how you will get the other cells. Well, that's a convolution of A and B. Okay, basically what we do here, we add up loss distributions, and you can do that if they are independent. Also note actually that the positive skewness of the loss distribution is now much higher. Okay, the highest possible claim is now 5000. You see before, okay, it was 3000, 2000, but now actually the overall claims can go up to 5000. So we have here a bigger positive skewness in the distribution. Now, when the insurance company now knows its overall loss function from both products, then it can actually again determine the amount of required funds to achieve a given probability of ruin, okay, maybe of 1 or 2%. Now, just as an example, in the preceding table, the total loss from products, the chance that the loss is bigger than 4,000, okay, is actually 2%. You see, okay, here we have the loss of 4,000. Now the chance that the loss will be bigger than 4,000, actually 5,000, that chance is 2%. So the insurance company needs to have the funds of $4,000, okay, if the probability of ruin should not be more than 2%. Now, if it has $4,000, okay, then with 2% chance, okay, it will go bankrupt. So the probability of insolvency will be 2% if, for example, the insurance company has an initial capital of 1,000 and there's a premium income during the year of 3,000. So overall, it will have 4,000. In that case, okay, it can actually cover those losses up to here, but it cannot cover the 5,000. Okay, so the probability of ruin will be 2%. Okay, that already finishes this lecture. Okay, thank you.